Welcome to the Introduction to DevOps. This module focuses on what is DevOps and the business and IT challenges it addresses. In addition, a real-world demonstration of an environment using a DevOps approach will be shown. DevOps, the end-to-end collaboration, monitoring, performance measurement, and process automation flow. It enhances the software development lifecycle between development and operation teams, getting from business idea to measurable customer action with speed, in minutes not months, being agile while also mitigating risk. Some say it can't be done. Some say it can only be achieved in the startup web app world, and the enterprise, well, they need never apply. However, in today's constantly evolving technology-driven world, companies, both web-based and enterprise alike, need to sustain a high level of performance, productivity, and profit. DevOps, with its technology, process, and culture-related trends, promises these high levels of achievement, whether its methodologies are adopted by the largest enterprise or the smallest startup. Now, the change agent, or reason to move to a DevOps model, can vary between both camps. For instance, a startup or web-based company might be more interested in getting their product or solution to market as quickly as possible, whereas an enterprise might be more interested in reducing risk and defects in their application. But there are also common and attainable goals shared by both sides. Let's meet the characters. First we have Michelle DeMonet, CEO of JetU. She is focused on the bottom line, business value, and making sure JetU survives this second to third platform transformation. Then we have Dr. DevCode, CTO, an eccentric but likable techie who thankfully is an expert on DevOps. Next we have Pete McLeod, a software developer who is a risk taker, wants constant change, and is very agile. Some people say, especially the operations team, that he's dangerous. Finally, we have Tom Rightway, the operations lead, who is very conservative and demands accuracy and stability. And then there's me. I'll be your narrative, no-name tour guide on this 10,000-foot view of DevOps. The company is called JetU. JetU is a major commercial airline. The company's core values are customer service and satisfaction. In addition, JetU's strength is in operations. Like most major commercial airlines, operations is a major factor in profitability. In this story, we will find out that through highly effective and feature-rich applications delivered efficiently to production for both customer and internal use, JetU will achieve its goals in driving profit, opportunities, and growth. Michelle, the CEO, has a problem. Customer satisfaction and profits are falling. Like many companies, customer satisfaction is often linked to effective use of web-based tools, social networking, and other second and third platform applications. Operations are also struggling. Cost management applications are critical to airline operations, and delays in new feature rollouts are affecting profitability.
Hello, Michelle. You asked me to come to your office for a chat. Whatever can I do for you?
Dr. DevCode, we have problems. We're losing market share customers, and our shareholders are not happy. Customers are having trouble using our applications, tools, and services. The applications are not addressing their constant desire for new features and functionality compared to our competitors. We can forget about getting the bugs fixed in a timely way. We have even bigger problems. We're behind the 8 ball. Our competitors are eating our lunch. We need to set up a war room to get these issues fixed. We don't have much time.
Michelle, slow down. Before we set up a war room, what are the issues?
The problems are many. But to sum it up, our applications are not keeping our customers engaged with feature-rich experiences, but competitors' applications are. JetU's internal business units need better tools to address flight, ground operations, and supply chain management. We're not able to provide bug fixes and enhancements, not to mention the creation of new applications fast enough.
I agree, Michelle. We do need better tools and applications. Applications are really becoming important to us in many ways. It seems that applications are often becoming the business. With what we have been discussing and the business issues you are bringing up, it seems to me that we need a different approach to defining, developing, testing, and pushing applications to production while being able to measure the results along the way. There is this movement that is gaining popularity. It is called DevOps. Have you heard of it?
I have heard of it, but I don't know much about it. Can DevOps help us?
Oh, I certainly think so, Michelle.
Great. What do we do next?
Well, first, let's get this war room set up and invite my top-notch developer and operations managers to help us out. Second, I think it's important to set the table with a number of key points that need to be discussed, like what are the challenges of the developer and operation teams, how to achieve business stability and growth through the concept of agility, the evolution of DevOps, and finally, DevOps is all about process flow.
Sounds good to me. Let's go.
Dr. DevCode sets up a war room. This is a common occurrence within IT following major disruptions to operations, development hiccups, detection of critical software bugs, or other unplanned situations, including outages. In this case, however, we will see that this problem is about how to get better at embracing new people, process, and technology methods.
I am glad we are all here. Michelle, let me introduce you to my team. My lead developer's name is Pete, and my operations manager is Tom. I briefed them on our earlier discussions, and they are both here to help us try to solve the issue of creating and building applications faster and better.
Thanks, Dr. DevCode. So the question is, how do we create the best applications for both our external and internal users?
Well, there's only one way to solve this problem. Create and push applications to production as quickly as possible. Cram every feature we can think of into each and every release. In terms of testing and debugging at the unit or system level, that's not my problem. That's for the operations guy to figure out.
There you go again, Pete. Always agile, quick, and a risk-taker, while I have to keep operations running and reliable. You are dangerous.
I'm not dangerous, Tom. You're just too afraid to try anything new.
Gentlemen, please, stop this fighting. After all, this is the war room.
Michelle and Dr. DevCode now give Pete and Tom a chance to explain their own individual points of view and challenges in more detail. First, Pete, the developer, explains it's all about the software development lifecycle. It's the need for speed. The first problem is time to production. It can take weeks to get code into production. This delays the deployment of features, bug fixes, and other enhancements. In addition, this delay also makes it difficult to juggle the management of old code and pending code mapped to new products and features. Then, when Pete's team finally gets code out to production, they often have dependency errors. This is usually caused by the work and associated changes being done in a development environment which is not replicated easily. As a result, the development code is often different than that of the production environment. Next, it's Tom, the operation manager's turn. Tom has challenges in many areas, and the first is maintaining continuous availability within the production environment. One of operations' major goals is to strive for 5 nines of availability. Plus, the number of servers, networks, and storage capacity is constantly growing, and it's very difficult to keep up. Also, being able to scale based on ever-increasing workloads is always a challenge. In addition, the tools he has to manage this growth has become less effective. Monitoring the performance that the customers actually experience is also very difficult. Then, when Tom gets new code from the developers, they are usually modifications that manually need to be made in order to achieve an effective deployment. As a result, a production deployment is usually scheduled weeks or months after a code release. Then, once the code is deployed, Tom and his team are solely responsible to diagnose any errors and fix it. He often feels that Pete is, to coin a phrase, dropping a bomb over the development/ops wall, leaving Tom's team to deal with the mess. Let's try and rephrase what both Pete and Tom had discussed. Operations is responsible for the availability of the application software in production, and its success is often measured with metrics that calculate server uptimes, server availabilities, security, capacity, and response times. These metrics are commonly defined as quality requirements that are signed as a service level agreement, also known as a SLA. As a result, operations' goal is to manage the user's expectations that all of the software features will be fully available all the time. If the software isn't available in production, this absence can be detected by monitoring systems, or even worse, by the users themselves. The operations team is then directly blamed for the downtime. This mixture of responsibility and direct perceptions from external users leads operations to focus on maintaining a stable production environment and its software. Every change to the production environment is risky and a potential cause of disruption. For the developer, the main task of the development team is to fulfill the customer's requirements, test the solution, and provide software updates in quick succession. New features that have been implemented and tested by the developers add potential value for the customer. So, on one hand, the development team wants change. On the other hand, the operations team is mainly interested in reliable and stable software. Every change forward by the development team can endanger the existing reliability and stability. For decades, CTOs like Dr. DevCode and IT in general have applied methods and adopted tools that lead to stability, minimizing risk. When an IT deployment goes badly, businesses lose customers and risk long-term reputational damage. Traditionally, business process innovation was bound by the slow but sure pace of IT's waterfall software development lifecycle, also known as SDLC. These IT development methodologies are rigorous, but slow and linear. But today, as outlined by Michelle previously, the business requirements change so quickly that if IT's pace is in weeks and months, you end up delivering nothing. This is because the problem changed by the time you finally deployed your solution. The question then for IT and the business is, if stability and agility seem to contradict, how does the business become more agile while maintaining a stable solution at the same time? Let's try and understand the reason for this stability versus agility paradox. Dr. DevCode continues to explain that speed versus stability should not be a paradox for IT. Many believe you can't have both, and pushing for both seems contradictory. However, today, IT organizations must strive to achieve this goal if the business' ultimate destination is to become more competitive and less vulnerable to catastrophe through competitive pressure. Michelle then asks, is it possible for us to accommodate a fast-changing business environment while ensuring stability in IT deliverables? Dr. DevCode then explains that it is, but it requires breaking with the safe yet rigid workflow principles of the past. One can no longer develop software by handing off detailed specifications to a software team to deploy it in a set-it-and-forget-it operational style. IT can transform itself by adopting agility without giving up stability. But CTOs must change the IT mindset about how to achieve stability. The key to this change is to adopt a development and operations philosophy that emphasizes speed and efficiency without sacrificing adequate stability. Specifically, CTOs can achieve IT agility and stability by making change a frequently recurring process. This can be done through the adoption of appropriate organic, evolutionary practices, often used by well-known web-scale companies. Dr. DevCode explains that the DevOps movement started in 2009. The goal was to evolve from more traditional processes such as waterfall, agile, and lean to more advanced methods of continuous integration, delivery, and deployment to the ultimate goal of continuous operations. But there is more. DevOps was described as a culture of collaboration between development and operations teams, often described as agile for infrastructure. The scope of DevOps has expanded into many other aspects of IT management, from tasks like software deployment and troubleshooting to quality assurance and security management. Operations in a DevOps way is emerging as the new way to do business in IT. To many people in the IT industry, DevOps is not a new way of working. Good IT organizations recognize that coordination and cooperation between groups provides huge productivity gains. For many IT environments, the traditional IT silos are going away. However, a huge number of other organizations are still trapped in these often considered dysfunctional silos. In this IT silo model, cross-team tasks still require complex handoffs and acceptance criteria, and response to failure is more about allocating blame than finding solutions. As the DevOps movement has grown, so has the concept. What in a simplistic way has been thought of as a communication channel between developers and IT has expanded to include the entire development lifecycle, with the inclusion of automation from the beginning of the process through the deployment of the solution in a system of incremental builds, such as that embraced by the Agile method. This idea is now formed another term, continuous delivery, which defines a pipeline approach in releasing applications. This approach has taken hold in many business verticals, especially for dynamic applications deployed on the Internet. DevOps is the culmination of three amazing and significant aspects: the Agile infrastructure, velocity, and lean startup movement. The proponents of DevOps are a community of practitioners using real-world experience to help define the transformation of software application development. The first significant movement in the journey towards DevOps is associated with the concept of the Agile infrastructure. An Agile infrastructure is an efficient and sustainable platform for offering self-service automation of heterogeneous infrastructure that includes legacy devices, dedicated data center infrastructures, traditional and emerging network components, private and public cloud elements. Being able to provide an end-to-end infrastructure in a precise, replicable, and easily usable manner to all stakeholders, including developers, testers, security and compliance, and people who deploy applications, is the key to an Agile infrastructure approach. There is also a need for end-to-end infrastructure agility. Line of business organizations need faster response times from IT in delivering applications that empower new product and market rollouts, and continuous business process improvement. While application development and testing can be performed on simulated environments, it is critical to make the true production infrastructure available throughout the entire dev test process. Without easy access to end-to-end infrastructure, serious quality issues are only discovered after going live, bringing an unacceptable level of risk, delay, and cost. For enterprise-class organizations, applications must often be integrated across many infrastructure stacks, including legacy systems, even non-x86-based systems, dedicated as well as hybrid cloud environments, and related network and storage components. The second movement in the journey towards DevOps is defined as velocity. This concept of velocity has to do with being able to deploy applications not within months or weeks, but multiple times a day. This was thought as impossible only a few years ago. The key enabler for achieving this is continuous deployment. Continuous deployment is continuous flow applied to software. The goal is to eliminate waste. The biggest waste in manufacturing is created from having to transport products from one place to another. The biggest waste in software is created from having to wait as the software is transported between states in the software development lifecycle, waiting to code, waiting to test, waiting to deploy. Reducing or eliminating these waits leads to faster iterations, which is the key to success. DevOps leverages the lean startup approach. It provides a systematic methodology in creating and managing startups, getting to a desired product into customers' hands faster. The lean startup method teaches you how to drive a startup, but is also applicable to the enterprise. The lean startup method shows you how to steer the company, when to turn, and when to preserve and grow a business with maximum acceleration. It is also a principled approach to new product development within a DevOps methodology. Many startups, business units, and other business entities begin with an idea for a product that they think customers want. They then spend months, sometimes years, perfecting that product without ever showing the product to the prospective client. In addition, when they fail to reach a broad market acceptance from customers, it is often because they never spoke to prospective customers and determined whether or not the product was viable in a particular market segment. This is also known as a minimal viable product. More on this later. When customers ultimately communicated through their indifference that they don't care about the idea, the startup fails. Using the lean startup approach, companies can create order, not chaos, by providing tools to test a vision continuously. For example, lean startup tools include the Pollinizer Lean Dashboard and Canvas that automates thinking, planning, and pitching an idea. One goal with the lean startup mentality is to eliminate uncertainty. Often startups abandon all process and take a just do it approach that avoids all form of management. But this is not the only option. Lean is about putting a process, a methodology around the development of a product. Another core component of the lean startup methodology in a DevOps approach is the build, measure, learn feedback loop. The first step is figuring out the problem that needs to be solved and then developing a minimal viable product to begin the process of learning as quickly as possible. Once the MVP is established, a startup can work on tuning the solution. This will involve measurement and learning and must include actionable metrics that can demonstrate cause and effect on the product in question. The startup will also utilize an investigative development method called the 5 Whys, asking simple questions to study and solve problems along the way. When this process of measuring and learning is done correctly, it will be clear that a company is either moving within the market drivers of the business model or not. If not, it is a sign that it is time to change direction or make a structural course correction to test a new fundamental hypothesis about the product, strategy, and solution, yielding growth. Finally, embracing a quick learning approach to the development cycle reduces uncertainty, and the development process time can be reduced substantially. When one focuses on learning quickly through a tight development loop while building the product customers want and will pay for, this approach will minimize the time required waiting for a product beta launch to change the company's direction. Adopters of a lean startup approach can adapt their plans incrementally instead. As we begin to fully embrace DevOps, the need arises to break down the traditional IT management model of structured silos around software developers, system administrators, network engineers, and security personnel. This previous top-down management style does not nurture the synergy needed for cross-pollination and non-secrecy to exist between teams. A more open and flat model within formalized teams better achieves this DevOps end goal. Dr. DevCode outlines this development process or pipeline flow of DevOps at a high level. The uniqueness of this process is the end-to-end flow of product definition through application development and test with tight integration points moving to production. Once in production, the importance of measuring the performance of the application is critical. Then, once the performance results are produced, the results need to be reviewed by marketing and the business in general, offering continuous improvement. This DevOps flow can then be broken down and mapped as shown into a set of principles, practices, and tools. In the 6-step development flow shown, you can now see how these various pieces fit within this stream. In many cases, development and operations overlap within the test phase, while continuous improvement, lean, and cultural value principles are used throughout all phases of the flow. The tool sets outlined are used primarily from the application development to production phases, while some are used for monitoring application performance in the measurement phase. Both Tom and Pete voice approval of the idea of DevOps. but are having trouble figuring out what to do next. In addition, they are still trying to get a grasp on what is meant by principles, practices, and tools as it relates to DevOps.
Dr. DevCode, even though JetU doesn't really use many of the development and design approaches you mentioned, such as Waterfall, Scrum, and Agile, I do know they've been around for some time. What makes the DevOps approach different in this regard?
Well, Pete, you are right that these design tools and approaches have been around for some time. But one aspect is missing. The glue that brings DevOps all together is using some core practices, principles, and tools. Practices are the way you get things done. Principles is the approach you take using various practices. What allows practices or ways of doing things to be efficient is having the right set of tools. The core principles of DevOps that brings it all together are the cultural aspects. Adding the human factor into the overall process flow is key. This is the power of DevOps. So DevOps' secret sauce is how we all relate as people to getting a job done. We all need tools and understand the best ways of doing things. But if we can't work as a team, treat people with respect, and have common goals, it makes our lives much harder. You got it. Let's take a look at these core points.
Dr. DevCode explains that a DevOps approach is achieved by operating through a set of practices, adhering to a set of principles, and finally using optimized tool sets and achieving higher levels of business value. First, you have principles, or the fundamental approaches that are not always technical and procedural, adding cultural and human factors into the mix. The second is practices, in particular pertaining to development, but there is much overlap to operations as well. There are different ways to develop code, from Agile, Waterfall, Scrum, and others. Lastly, there are tools. Tools help in the automation process in all steps of the software development lifecycle. Michelle thanks Dr. DevCode for showing the various practices, processes, and tools needed to achieve a DevOps approach. They all now agree that this new open, collaborative, and automated style will yield some great results. Now they are trying to understand where they are as JetU in this journey to a DevOps world. How do they evaluate their own state of DevOps readiness? Michelle asks, are there maturity models that can help us in that regard? Fortunately, there is. DevOps is more the journey than just the destination. Dr. DevCode suggests evaluating the different maturity levels leading to a fully optimized DevOps approach. This will help JetU figure out where they currently are in their own DevOps journey. He then explains a maturity curve outlining the various stages an IT department can go through to achieve a full DevOps approach. Ad hoc, opportunistic, repeatable, managed, and finally optimized. Each subsequent growth from one to the next will further drive business value for JetU. With ad hoc, the DevOps discipline is often difficult to communicate and initiate. The business and technology organizations are often political and risk-averse, with deep levels of mistrust and limited teamwork. Finger-pointing across silo-based teams are prevalent. Responsibilities are often blurred and tools are silo-based. IT and the business usually find it difficult to communicate or understand the business strategy. The next level is called opportunistic, and this is where process standardization and an increased focus on teamwork across development and operation teams occur. Technologies are used to automate certain features and reduce the overhead of script management. Tool rationalization has begun. Automation in groups across development, testing, and operations are being embraced. Teams are being asked to try DevOps and not be afraid of failure. In this stage, defined as repeatable, DevOps is driving the integration of blended teams that includes representation from the business unit or stakeholders, development, testing, and operations staff. Repeatable processes are in use at this point. There is an expectation that they work as a single team, sharing and collaborating together. Common metrics are also in use to drive unified behaviors for the team. DevOps is seen as a way to accelerate time to market that fits the speed and flexibility that Agile, Scrum, and Extreme Programming offers. At this stage, the Managed DevOps organization might be seen as a Center of Enablement, or COE, where the DevOps discipline is taken into multiple groups and driven to deliver business results. There is often an increased focus on quality across all aspects of service delivery, with continuous feedback mechanisms built into the process workflows. The need to gather improvement inputs from both internal staff and external customers begins to take form. The budget and cost modeling processes enable blended teams to create a unified view of a service from development to deployment and operations. Finally, the optimized stage is characterized by customer-aligned service delivery, whereby the values, processes, and procedures encapsulated in the DevOps discipline become generally accepted and utilized. Both business stakeholders and customers provide feedback at various stages of the service delivery cycle. IT cultural transformation continues as incremental DevOps successes take shape and are communicated through the business and IT organizations. Businesses and IT have similar, if not the same goals and objectives to drive competitive business advantage. The COE enables a pathway to accelerate business value and acts as a catalyst for active improvement as new IT capabilities are developed and deployed in an automated fashion. Now that we understand the maturity model that IT can follow on their DevOps journey, let's see a real-world example in action. EMC is leveraging their Enterprise Platform as a Service, or EPAS, portal towards their own DevOps journey, driving business value through continuous integration and delivery of applications. Hello and welcome to this video tutorial. This is a real-world environment that automates the DevOps process and flow. Using this portal, EMC IT's internally developed EPAS, or Enterprise Platform as a Service solution, delivers a single project view for both development and operations. The portal has 8 views. Each view is associated to various aspects of the total software development lifecycle in line with the DevOps flow previously discussed. Let's take a look at the dashboard view first. The dashboard provides platform outlays and application infrastructure purchase information via a speedometer, providing cost transparency. This is a self-service model in line with DevOps cultural empowerment goals. One can easily determine resource allocation, be it in development, test, QA, or production. You are only billed for what you use. This portal allows barriers to be broken by inclusion of all team members, driving trust and cultural values, which are key DevOps goals. This is done while maintaining enterprise security, data protection, and monitoring. One can define team members' rights and privileges, providing a way to share responsibilities in an open and collaborative way. For example, we can add Tom as a developer, a tester, and a member of the support team. After all, part of the DevOps movement allows individuals to have multiple roles and responsibilities, as opposed to gating individuals to siloed technology teams. We then see the corresponding updates being made and the associated roles and responsibility alignments updated. This form of team member alignment allows each participant to have specific rights to log files, performance data, and other measurement tools. Other rights can be to check software into a source code repository and execute jobs within the continuous integration lifecycle as appropriate. The application SDLC section allows the creation of the various artifacts that are required to build an application. These entries control the various instances that are needed through WAR files to the deployment targets. For example, a code repository such as Subversion, a Jenkins build, server, and an archive repository can be built in the development instance. Other useful links are here. One of the key aspects of a DevOps approach is to provide automated measuring and monitoring tools such as the VMware vCloud Operations portal. It also gives access to the Log Insight portal, offering varied views of the log files themselves. In addition, you will have access to all of the performance data of an application. Performance monitoring is key to DevOps. Another significant aspect of EPAS and the DevOps flow is to log all changes, updates, and modifications within the SDLC flow or process. Being able to view the history of all changes and associated costs drives trust and security from development through production within a DevOps culture. The first step in platform creation is to define a topology of the infrastructure supporting the application. A topology creation process is the way EPAS creates environments or instances that are repeatable and consistent between development and production, for example, which is a crucial step towards higher levels of maturity in the DevOps journey previously discussed. In this example, we are going to build a traditional three-tier application stack, which includes a web server, application server, and database server. Let's select an Apache web server, Tomcat server, and a Postgres SQL database server. Then let's click Apply to update the topology framework. The EPAS environment then creates a logical wiring diagram as to how the components are connected. Part of DevOps is to support an agile infrastructure. Using this topology configurator, the infrastructure can be configured in many ways, allowing tight alignment to business and application requirements. Now that we have a well-defined topology, we can then be ensured that all instances, be it development, QA, or production, are consistent. Let's start with the development environment instance. Continuous integration environments are used in DevOps to automate, build, test, release, and deploy processes. When code is checked into a source code managed repository, build software scanning this repository notices the new code and automatically builds and redeploys the resulting application within the environment. This automated tool chain helps developers immediately gauge the results of their updates and can be easily duplicated across production, staging, test, and sandbox environments. In this case, the environment we're going to start is in development. The SCM we're using is Subversion, and the build software is Jenkins. When a development environment is set up, a developer would interact with it by checking their code into Subversion, which then gets deployed into the environment via Jenkins. The application's performance is monitored via Log Insight and VCOPS and custom testing tools. Let's set up the development environment. Here, let's specify 2 VMs for our web server tier and accept the defaults for the remaining settings. Notice the increase in cost, which is based on a monthly run rate. Now, let's add 2 VMs for our application tier as well, and bump the memory up a little since we'll be running a Java application. Notice again the monthly cost increases after requesting more resources. Now let's build our database tier. We'll request only 1 VM here, but we'll increase the amount of processing, memory, and storage used by the Postgres database. Here is the total monthly run rate for our 3-tier application in a development environment instance of the EPAS. Clicking Checkout would build the systems we're requesting in about 15 to 30 minutes and be ready to accept developers' code drops in under an hour. Back on the dashboard, we can see that the overall project resources requested so far is reflected in the platform cost meter. With a $50K sample budget, we're well within our means and currently operating at only 29% of the total monthly budget with some room to grow. A cornerstone of DevOps, which is self-service, enables both developers and operations to procure additional environments and resources. In addition, with EPAS, you can also keep track of expenditures to make better informed procurement choices. Each environment can be individually adjusted as well. Let's say on day 2 of operations within the development environment, developers suddenly realize their application's web tier needs more memory to handle a larger volume of web requests. They can easily scale up the RAM in the same way as the initial environment request. The cost updates here. I'll save this and note a similar change on the dashboard. Also note this update in the order history from day 1 to day 2 of operations. Scaling could be done in the same way in production to handle growth in the numbers of users, for example. This concludes the demonstration. Thank you for your time.
Dr. DevCode, that was a really great demo. I really like how the ePaaS portal allows you to create a well-defined topology that provides consistency between all the environments. If I can feel comfortable knowing environment configurations between development, test, QA, and production are going to be kept in sync, our newfound flexibility and agility don't seem as scary.
Yeah, the demo was great, and I personally like how the ePaaS portal promotes self-service. I saw that the developers were able to scale down their own application environment resources, be it adding more VM, CPUs, or RAM. Also, and to Tom's earlier point, if I can be assured that development and test environments are going to mirror those in QA and prod, shoot, this means we can finally keep up with our customers' feature requests. We could push all the new features of Tom's team much faster, since it would be less worry that any of these would need to be retested in production. That's pretty powerful stuff.
Also, from a business perspective, I see how having an overall process flow, from product definition through production, measuring effectiveness at every step. Even from a financial perspective, would truly yield customer satisfaction driving business value. It's interesting that with all this talk of the third platform, cloud, mobility, big data analytics, and social business, all this is dramatically raising the bar for defining, developing, deploying, and running software applications. As software is becoming the critical component of sustainable competitive advantage for businesses, IT organizations must continuously deliver customer-aligned functionality faster and with increasing levels of quality and security. Business pressures continue to increase on CTOs across all aspects of IT service delivery. That creates a sustainable competitive advantage through IT investments across staffing, culture, technology, and processes, and is a critical requirement for driving business growth and enabling agility. Specifically, the roles and responsibilities of development, testing, and operations teams are being transformed by automation, cloud platforms, agile, and process standardization. This transformation is forcing significant organizational and cultural changes and has helped create a DevOps discipline that offers significant business, process, and technology value.
Dr. DevCode, I think I'm really getting it now. I always thought developers should care less about team effort, more about just getting the job done. Tools? Well, I thought automation is just for the ops guys. Now I see that automation tools through the whole software development lifecycle will help enable DevOps, be it a developer or operations team member. I also realize that tools are only a small part of the equation, as they require process and culture support to return maximum value and transcend the IT silo mentality we have around here.
I'm also glad to hear that DevOps really focuses on addressing the IT culture of collaboration, teamwork, sharing. Empathy, communication, things like trust and quality, and of course the need for measurement and metrics. Traditional operations have always had many of these goals in mind, but I'm glad DevOps is bringing them into full view. Pete, you are no longer dangerous.
I agree, Tom. I also thought continuous delivery was just an application development lifecycle thing and leaves out the operations teams. I was wrong. I realize now that we need cross-pollination for DevOps to really succeed, which includes development, test, and release, and operations. Tom, similar to you seeing me as less dangerous, I also see you as less cowardly. Risk-averse. We are finally working as a team.
Excellent. You're really starting to sound like DevOps experts.
Wow, we've come a long way. I'm glad we set up this war room and battled out those issues. I know that this new way of service delivery will really help the business and allow us to focus on current and new opportunities for business value creation and customer-aligned service deployment.
I think it's clear that you've truly learned to stop worrying and love DevOps.